All right, guys, let's continue. This is part 2 of lines and triangles. Sorry, I kind of had to duck out at the end of the last one. My mouse was going crazy. So this was the result after our second line. We took a look. We had the computer construct the 3 angle bisectors. Again, it created a concurrent intersection called the in-center. It's called an in-center because a circle can be created on the inside, perfectly touching all 3 sides of the triangle. All right, so we looked at perpendicular bisectors, had a circle going around the outside. The circumcenter was what the name of the concurrent intersection. It's the angle bisectors is called the in-center. And now let's go look at the medians. All right, a median connects the midpoint of one side of a triangle to the opposite vertex. So that would connect E to A. This midpoint would be connected to the opposite vertex. And this midpoint would be connected to the opposite vertex. Again, we have a concurrent intersection. Doesn't matter what I do to this triangle, we're going to have that intersection there. What do I selected? Boom. This line, construct intersection. Okay. For medians, that intersection point is called the centroid. Happens to be the point of balance of a triangle, which can be really important with construction and engineering objects and trying to know, especially like items like airplanes. You'd want to know where the center of balance of an airplane is. So this is a truly applicable mathematical idea. Now, with medians as well, there's another quality going on. With medians, there's also something called the Centroid Theorem. And I misspelled that. The Centroid Theorem, if you see each one of these segments is broken up into, each median has got a small section from like F to O and a long section from O to B. Every one of the medians, all right? If we look at median AE, there's a small section and a long section, okay? That long section there, all right, is always going to be 2/3 of the total median. Let's not do 18, let's go. All right, so this will be 2/3 of the total. That means this small piece, if you're doing the math in your head, what's the rest? That's 1/3. All right, so no matter what, all right, OF will be 1/3, OB will be 2/3. All right, so just realize the centroid theorem, all right, that means that the median will always be broken into a 2/3 and 1/3 section. Like certainly, if I gave you some of those values, if I told you the measure from O to F, if I told you that OF was 6, I would want you to know that OB, which is the 2/3 portion, would have to be 2 of those, which would be 12. And the entire thing, BF, would have to equal all 3/3, which would be 18. Okay, it's just an example type problem. Let's make sure everybody knows that's an example. All right. So make sure you get some practice in on that. That's medians. And the last one, an altitude connects a vertex the opposite side perpendicularly. All right. So if I want to connect a vertex to the opposite side perpendicularly. So it's not necessarily going to hit the midpoint of that side. That's an altitude. How many altitudes can we create in a triangle? Every time the answer is 3. So I can go from this vertex to the opposite side, making it perpendicular. Last vertex, connecting to the opposite side. Last but not least, we have, again, a concurrent intersection. I don't need you to really memorize the titles of each of these. The orthocenter is what this one's called, that intersection point there. This line, if it intersects with the other 3. Point P here would be the orthocenter. When it's the medians, it's called the centroid because it has different qualities, different characteristics. The angle bisectors has the incenter. That's the circle that's created on the inside. The perpendicular bisectors have the circumcenter. All have different qualities and characteristics. And the additional, the medians, don't forget that centroid theorem, where each piece was broken into a 2/3 and 1/3 section. All right, a lot of mathematical possibilities to create in all of these sections. This is not very easy. You certainly will need to identify. If I gave you one of the lines in there, you'd need to know which one I'm pointing at. You'll certainly get that practice on the homework. Okay? Thanks for listening.